My name is Brendan College, and I'm presenting a Build a Catapult project for high school physics students. This is my prototype catapult that I built. First, I'll go over some recommendations for building your catapult, why I built it this way. In this project, you're going to do some test shots to try to figure out the angle that your ball goes at and its velocity, so that you can do a shot later at a different elevation or different angle and try to hit a target on your first try. So it'll practice building things, measuring things, and using algebra with parabolic equations, equations of parabolic motion. Now there are a couple of reasons I built the catapult this way. You could make a catapult with a throwing arm, but that's probably harder to tell what angle it's being shot at. So I made a straight rail for the ball to go down, so I could easily calculate the angle it was shooting at. And I recommend using a fairly weak spring or rubber band so that you won't destroy your mechanism. And also, at a given force, a weaker spring will actually impart more energy because it can stretch farther at a given force. And I have a mechanical hold, so I can, I'll show you in a minute, you can pull it down and put the fishing line into the hold and it'll stay there. And then I can push down on the paper clip and it'll slip through my finger, and that's to make consistent shots. Now that's very important, because if you just used your hand, it probably wouldn't be consistent shots, and then probably none of the math you would do would be very accurate. So I think that's that. So there are going to be two main shots you do: practice shot or shots, and that's just to see how far the ball goes and measure it. I've done it already and done the math, but we can do it again just as an example. And then the second shot will be at a different elevation or a different angle. That dog is very annoying. At a different elevation or different angle, and you're going to use what you calculated previously to try to predict where it's going to land. And you're going to try to hit like a little target. I have like an army figure. We're going to try to hit him on our first try. We're probably going to get close, but not quite, because there's like air resistance and like maybe I don't aim just right or something. But I'm pretty sure I did the calculations right. So I'll show you a test shot. So this shot, you would do lots of measurements, like this is. I've done it already, so I'm not going to do it again. You get a tape measure and measure how far it went, and then you can use that to do your next calculations. Oh, that's neat. It landed just at the end of the door. So that would make it easy to measure how far it went if it hits something very easy to see. So basically I would measure from here to there and how far the height the catapult is, and try to get a triangle and figure out what angle it's going at. I've done it already. Yeah, so the range is consistent. I'm not sure what the proper way of aiming this thing is. Okay, I'm ready. So this is going to be my first real shot to try to hit the target, and I've honestly never done this before. This is my first time. I'm not sure how close it's going to get. I used the previous test to calculate that this time I should be 234.6 inches away from the target. You can see I'm up on a raised surface, so it's not going to go the same distance as before. So I'm going to see how close I get. Okay, I'm going to shoot again. I've nudged it a little bit, so hopefully it'll get a bit closer. I'm going to move it forward a bit too, because it was a bit short. That range that was even further off than before. Okay, now I'll provide you with commentary about the experiment I just did with the catapult. First I want to say thank you to my dad for filming. And next I want to say we could have made the video a bit better. For one, it would have been easy to make the dog stop barking, and maybe could have taken some better shots too, or had some better dialogue. But this project's due in a couple days and I just want to get it done. Now as for the experiment, I wish I had tested the Catapult a bit more before doing the official run. I was very careful to get the range right, and so my dad and I both agreed from eyeballing it, it looked like the ball only fell about 2 inches short in terms of range, but it was about 6 inches away on the first shot total, meaning most of the error came from the side-to-side motion rather than the range. We talked about that a bit. My dad suggested that you could tape a piece of graphing paper down to a surface where you are going to fire your catapult. And that serves two purposes. One, it shows you where the catapult was so that you can know better how to adjust the catapult. And secondly, if you accidentally nudge your catapult, that doesn't ruin your next shot, because you can just, you mark down, you can see where you put your catapult because you marked it down. I came up with another idea. When I was aiming, I was looking through the rails like this, and there was no toothpick at the time, so I just put the target in the middle. I think the toothpick would make it much better because it's a narrow target. And also, if, let's say, the ping pong ball appears to fall like 5 inches to the left of your target on the first shot, after you line up the target with the toothpick, on your next shot, you just put the target what appears to be 5 inches to the left of the toothpick, and then when you fire, you'll probably hit it or get really close. We didn't come up with a good idea for finding out where the ball landed before we did the project, but we had the idea afterwards it would be a good idea to fill a tray full of sand and comb the sand flat and put the target in the middle of the sand, and then if the ping pong ball lands close to the target, you'll see there'll be a mark on the sand where it landed, and then you won't have to guess. And we thought maybe we could use the camera to find out where the shot landed, but I don't think you can actually do that because of perspective. I looked at the video, and both when we were shooting at the door and when the ping pong ball was moving toward the target, the ping pong ball appeared to be farther away than what it really looked to be when we were actually doing it. I think the reason is perspective, like I said. That doesn't happen when you look at it with your eyes because you have depth perception with your eyes, but the video doesn't have any depth perception, so when the ball is in the air, it would be very hard to tell where the ball actually was unless you were filming directly above the target, and then you wouldn't have that perspective issue with respect to distance from the target on the surface. I think that's about everything I wanted to talk about. So yeah, when you're testing your catapults, you should test side-to-side motion as well as the range. You could use sand to find out where the ball went. I suppose this is a good demonstration of why it's good to test your projects before you give them to your students. And I could show you one more thing. I don't know if you saw how I bent the paper clip so that I can hold the ping pong ball. That's the paper clip right there. And so you can pull this fishing line down into the paper clip, and the paper clip will hold it like that. And then I can show you from the other angle, this one. Then when I push down on the paper clip, the fishing line will slip between my fingers and fire. Alright. So this is how I would score it. From eyeballing it, it looked like the ball missed by about 6 inches, which is about 15 centimeters. If I were going to do this again, I would use the tray of sand. So the way you score it is your range divided by how much you missed by plus 1 centimeter. The 1 centimeter is just to keep you from dividing by 0. So that would mean I would get 595 centimeters divided by 16, which is about 37 if you round. So the first time I got about 30, according to my scoring system, I would get about 37 points. Then, assuming I missed by about 6 inches the other two shots, which is reasonable considering I shot about the same each time. You would have your score every time in round. So that would be 18 the next time and 9 the time after that, for a total score of 64. I also thought about what would happen if I had figured out aiming side to side before I started shooting. And I think my first shot would have probably been about the same, but I probably could have halved, just guessing, I think maybe I could have halved the distance I missed the second shot, and maybe I could have gotten lucky and hit it the third shot. And if I had hit it the first time, I would get 149, I would get 595 points. But if I hit it on my third shot, I'd only get 149 for that. So if I had worked as hard at aiming side to side as I had figuring out the range, I would have potentially gotten upwards of 200 points with the apparatus I have right now. So that's how the scoring would work.